So in this problem, we want to look at stock solutions and the dilutions of them. So in this case, if we have a stock solution of 14.8 molar ammonia, how many milliliters of this solution would you use to create a 1 liter vat or bottle of 0.250 molar ammonia? So in this case, we're going to use M1V1 equals M2V2. So the first thing I like to do is to write down over here all of the values we know, so we make sure that we set this up exactly correctly. So we have 2 molarities. So M1V1 equals M2V2. So our first molarity in this case is 14.8 molar. So this is our unknown. So molarity 2 is 0.250. And the second volume is that we just need 1 liter of the total solution. So when we set this up, we have 14.8 molar is going to be equal to V1, which equals 0.250 molar times 1 liter. So when we plug this into our calculator, we have 0.250 times 1 liter divided by 14.8. And so we get that V1 equals 0.01689 liters. But the question asks how many milliliters, so we need to convert this value. Liters times in 1 liter, there are 1,000 milliliters, which gives us 16.89 milliliters. But we need to double check our significant figures, 3, 3, and 3. So our value needs to have 3. So our final answer is 16.9 milliliters of the stock will create 1 liter of 0.250 molar. Now, in the second part, it asks if we take 10 milliliters of the stock solution, which is 14.8 molar, and we want to dilute it to a total volume of 500 mils, what is the concentration? So we're also going to use M1V1 equals M2V2. So let's reset up our values here. So the first molarity comes from the previous part of the problem, which is 14.8 molar. And it tells us we're going to add 10 milliliters. So in this case, it gives you a total volume. So we know that the volume of solution 2 is going to be 500 mils. And so we're looking for M2. So we have 14.8 molar multiplied by 10 mils gives us M2 multiplied by 500 mils. Now, one of the benefits to using this equation is that we can cancel out our units and we don't need to convert these to liters. So when we plug this into our calculator to solve for M2, we have 14.8 times 10 divided by 500. So we get that our second molarity is 0.296 molar. Now we want to double check our significant figures, which in this case are 3 and 4, and a 3 up here. So our value has 3, and so that is the final answer.